Let us prove that the product of negative a and negative b is equal to the product of positive a and positive b for all a and b element of real numbers. This is still part on the review on the algebraic properties of real numbers as part of the preparation for the topics on real analysis. Hence, we are going to use here the algebraic properties of the real numbers in order for us to show that the left-hand side is equal to the right-hand side. Now, let's have this proof here. First, let a and b element of real numbers. This for us to use the algebraic properties of real numbers. Then, we are going to show that the left-hand side, the product of negative a and negative b, is equal to this using the algebraic properties of real numbers. So, by looking into this, since this is by a product, we may introduce here inverses, specifically multiplicative inverses. We will have this form, negative a times negative b. Let's have times 1 times 1. We are introducing the product or addition of two ones that will be multiplied to the original form. And take note that 1 is the multiplicative inverse. Hence, it doesn't change the value on the left-hand side. But we are doing that to introduce two sets of additive inverses which could lead us into our goal. Let us have here negative a times negative b. Now 1 can be rewritten like this. It could be the product of a times 1 over a. A and 1 over a are multiplicative inverse of the other, and when we multiply them, they will just result to 1. So hence, we are not necessarily changing what is the value of the left-hand side. Similarly, since we have b in this form, so let's also introduce b times 1 over b. Still, product of two inverses, multiplicative inverses specifically, will result to 1. We are doing this because we can see here that we have our a, positive a, and positive b in this expression now, which is the goal of our left-hand side here. So we just need to apply other processes for our properties of real numbers in order for us to arrive at that. Let me do it like this. Negative a times negative b. Let me remove the grouping symbol. Times a times 1 over a times b times 1 over b. Okay? Now, let me apply here the commutative property of multiplication, where I can just rearrange the terms in this manner. You have negative a times 1 over a times negative b times 1 over b times a times b. So that this is already arranged to our goal. Okay? And with that, after applying the commutative property of multiplication, which allows us to interchange the coefficients, we can now apply here associative or groupings. Let me have the grouping here of negative a times 1 over a. Okay? Times, you have here negative b times 1 over b times a times b. And with this, we can now see a certain negative factor here, which we could just take out. So we'll have here negative, we have here a times 1 over a. Similar thing for our negative here in our b times negative 1. Let me make this negative 1. Times, you have b times 1 over b times a times b. We are doing this because this are just products of multiplicative inverses, and then similar to what happened earlier, they will just result to 1. So you will have here negative 1 times, this is 1 times another negative 1 times another 1, let me place parentheses, times a times b. Now we will have here negative 1 times 1 times negative 1 times 1. We have proven also another property which states that the product of two negative 1s is just positive 1. So that's just equal to positive 1 times a times b, which will result to just a times b. look into our goal. That's our goal here, showing that this left-hand side is just equal to this right-hand side. Thus, we can have shown that the product of negative A and negative B is equal to the product of positive A and B, where A and B are real numbers. This is the end of this proof. Thank you very much for watching.